Greetings everyone and welcome to the Mobile IT Community of Interest, the monthly meeting for February. Thank you very much for joining us today. Before we get started, I would like to review how to use the GoToWebinar system in order to optimize your experience today. I'll briefly explain how you can interact during these community meetings using the GoToWebinar system. You've all been put on default mute settings due to lots of participants on the call. However, you can get the audio over telephone or the speakers of your computer to improve the sound quality if that's needed. The panel is set to hide automatically. Please use the orange arrow to show or hide the control panel as you see fit. You can change this setting on the view menu at the top of the panel. You're encouraged to forward any questions that come up during the presentation using the questions tab. The questions will be read and answered, hopefully, after the presentation. And we will identify, if so desired, who's asking the questions. If you don't want to be identified, we don't get too many of those, but if you don't, please say so. And we will also have some live polls just prior to the questions. These are multi-choice, and you can click your answer on the screen and the choices provided. And finally, at the end of the meeting, we'll mention the follow-up survey. If you can, please respond to the questions so that we can incorporate your feedback into the work of the community. So thank you now, and we will start the presentation. I'm Stuart Young. I represent Fiatech in Europe and the Middle East. On behalf of all of us at Fiatech, I'd like to thank you for joining us today for the Mobile IT Community of Interest monthly meeting. Today's presenter is Dr. Maxwell Mallia-Parfitt, who will present the 3D Move project, a mobile visualization environment for construction applications. Before we get started to the presentation, I'd like to take a minute to introduce Fiatech and this community of interest to those who are not members of Fiatech and those who are new participants to the community. Fiatech is a member-based organisation with an objective of improving the productivity of the capital projects industry through the deployment of technology. There are nearly 100 member organisations partners, including academia and subject matter experts, and we welcome new members to participate in our activities. Our goal is to improve productivity in the capital project sector through the adequate leadership in global development and adoption of innovative practice. We strive to accomplish by enabling our participants to advance industry practice. If you're interested in getting involved or would like more information, please drop me a line, young@fiatech.org. State of mobility in construction. In Fiatech, we strive to solve practical problems and the challenges associated to implementing mobile technologies which are of a practical nature. Mobility in particular, and contractors in the industry have observed improved project performance in collaboration, productivity and cost-given increments in information mobility. Despite these benefits, investment in information technologies and IT staff development continue to be a struggle in the industry. This is behind other industries with this type of investment. We believe that to advance the capability of the industry, we need to invest and harness the benefits of information mobility. It is necessary for the different organisations in the industry to come together as a whole. So about this community of interest. At the core of Fiatech's interest, we have created this community of interest in mobile IT. The objective of the community is to showcase the mobility solutions that will be adopted in the capital projects world. We intend to achieve this by presenting the latest cases of mobile IT adoption and also by allowing the breadth of community participants to expose their perspective on these technology applications. We have been delivering use cases and industry perspectives through various channels, including these monthly meetings, virtual and live discussions, documentation and reports from these gatherings, and also by facilitating the creation of research and development projects within Fiatech. Furthermore, this community is a joint venture between Fiatech and COMIT. COMIT is a UK-based organisation. COMIT is an acronym for Construction Opportunities for Mobile IT. Its principal aim is to learn from experience to deliver measurable business benefits in terms of adoption of mobile technologies. As such, this partnership supports the work and objectives of the community. I've been asked this question a number of times: who's involved and how many people and where are they? This community of interest is now 1 year old as of 3 weeks ago. Throughout the last 12 months we've had more than 850 participants from 350 organisations located in 41 countries around the world. Main participants are located in North America and Europe, but as we continue to expand in the Middle East, the Middle and Far East, as well as South America, we're attracting more and more participants from different countries. We're very glad with the industry's response so far. We get asked lots of questions, and we're continually working to meet the needs of our participants and answer those questions. So, I'll move on to the main presentation. Today, as I mentioned earlier, we have Maxwell Mallia-Parfitt, who will present a mobile visualization environment for construction applications. Maxwell received his PhD in computer science from the University of Reading in 2013, where he also completed a Master's of Research in Advanced Robotics Design and his bachelor's degree in Cybernetics and Computer Science. Maxwell continues to research and teach at the University of Reading in the Design Innovation Research Centre. Here he is responsible for continued research into new visualization techniques for BIM and CAD data, concentrating specifically on development of new visualization technologies and building a repository of models to inform and teach future students within the School of Construction Management and Engineering about BIM and asset management through visualization. Maxwell's recent research and development work on visualization, including user testing, has been highly commended by the Chartered Institute of Building. Maxwell, I'll now pass it over to you.
Okay.
Thank you very much for participating.
Thank you. Right, well, hello. As Stuart has introduced me, Dr. Maxwell Mallia-Parfitt. There are my email and Twitter handles if anyone wants to get in contact and discuss things. Also, a slightly different title from the one that Stuart had in his slides, but all around the same area. So today, I'm assuming if I click on the slide, it goes. Sorry, Stuart, do I have control?
Yeah, just a second.
Aha, hang on. 2 seconds. Right, show my screen. Stuart, can you see my screen? Can everyone see my screen?
Yeah, got it.
Hooray. Right, so today, as a quick overview, I'm going to be talking about why actually use visualization, a quick history about visualization and some of the uses in construction. Then looking at the differences between visualization, augmented and virtual realities, and how these are used with big data. And then the bulk of the presentation is going to be around the research that I've been performing over the last 20 months here at the University of Reading, working with industry partners to develop the 3D Move, a mobile visualization environment for construction applications. And then at the end, before the poll questions, going to have a quick look at where we're going in the future. So before I start, some acknowledgements. My research is heavily funded by the EPSRC, and it's funded through the Design Innovation Research Centre, which was founded as part of the Challenging Engineering Exploration Group. Also working very closely with Crossrail, who have been very good industrial partners, giving us access to model data that we could use to test our equipment. Also a shout out to the software providers, so just alphabetical order here: Autodesk, Bentley, IMVR, NVIDIA and Unity, using these software from these providers on a daily basis. There are others, too numerous to list, but those are the big 5. So thank you to everyone listed. So, a quick history of visualization. Visualization is the technique for creating imagery or diagrams to communicate messages. And these can be traced all the way back to cave paintings, Egyptian hieroglyphs, and things like Leonardo da Vinci's methods for actually drawing scientific and technical and engineering drawings. In recent times, these have been 2D views of three-dimensional data using either paper printouts or computer displays, but increasingly now we're seeing the move into fully immersive visualizations, so being able to step physically into the 3D world, whether this is using head-mounted displays or cave-type environments, and we're going to have a look at some of these later on. So visualization in construction is growing rapidly. Construction requires a detailed, in-depth knowledge of data sets that are very highly detailed, and we need to be able to access this information in a way that's easy to understand and draw out. Any visualization of BIM and CAD data must be accurate. Without accuracy, there is no confidence in data. The data must also be current. Far too often, people have pulled up a model and it might be 3 or 4 months out of date. So the data they're accessing must be current. The data also must be accessible, so it doesn't matter whether you're out on site with an iPad or in the office with your CAD center, you need to be able to access the latest data, and it's got to be reliable, because if it's not reliable, then quickly we find problems cropping up and we lose trust in the data. Along with this, there are some issues. So there are many different modeling formats, and this is down to proprietary software formats such as Autodesk and Bentley. They have their own types of software, they have their own modeling standards, and this leads to some mistakes and problems. So things such as suitability of data for visualization. If you're wanting to take an engineer in to do an MEP fit within a plant room, chances are you're not going to need a library of chairs for them to access. But also you're wanting them to access enough information to do their job efficiently. Also, the level of detail in models, it sounds a bit stupid, but I have seen screws, the threads put onto screws, and even the manufacturer's logo embossed onto the screws. Now, really not necessary unless you're doing the interface between the screw and the nut that it's screwing into. Generally, you just need to know that it's there, that is the location of the screw. So the level of detail needs to be suitable for the visualization at hand. Also, heavy federated models, the idea of agile engineering, being able to have small models that are highly referenced. So if you change an object, only that part of the model needs updating. And I've seen this in the past with large models. They've been sort of 2-3 minutes to update, but once federated, so removing all of these references and squashing it into one big model, it could take up to 20 minutes, even just to rotate the model. And I've seen people go away from their computers, get a cup of coffee, come back, and the model is still loading. But also, one of the big issues that we're seeing, and we're coming across this time and time again, is the conversion of data to ready for visualization. How do we actually get the data in a usable format so that we can go out and use it efficiently? And this is something that we've been working on at the university. So hopefully you've all seen images like this before. This is a city level plan showing different build times, but also then we've got static rendering of 3D, so a statically generated image of the same environment. Now, they can only give us so much information. They're very clear to look at, but they can only give us so much information. And this is where we're leading into the use of augmented and virtual reality. So AR and VR generate real-time, three-dimensional imagery of entire environments. So we can go all the way from a building up to a city block, even to an entire cityscape. We can go underground and look at pipework, and we can even model GIS, so we can start looking at landscaping. Now, these virtual environments allow users to freely explore and move through a model, and they can also then access underlying data sets. So they can go in and grab information out of a COBI data file. They can link in with Synchro and look at 4D scheduling. They can then take certain information such as, is this a brick wall? Then we can render it as a brick wall, but also document management. So being able to then pull out information such as who signed off on this bit of work, when is this pump next needing to be greased, and being able to actually pull out all these different types of information and interact with them in one interface. And augmented reality and virtual reality becoming much more widely used in the construction sector because they aid effective communication and decision making. People get a feel for the data a lot quicker than trying to extract the information from a 2D plan on a piece of paper. Also nowadays, most projects are either utilizing CAD or BIM, so 3D models are available. But the big one here is the accessible technology. The cost of technology is coming down rapidly, and it's becoming simpler and easier to integrate models with augmented and virtual reality. So, a quick example of augmented reality. Here you see a 2D printout of a plan view of a building. There are some fiduciary markers around this plan that allow a user with an iPad to walk around the plan and see a 3D rendering located on the plan. And this allows a user to then explore and interact with the data in a much richer way than is possible just from looking at the 2D plan. But going out and taking this onto site, what you can see in the top left-hand corner of the image is a worker here with a tablet device aiming at a fiduciary marker on the floor, just positioned within the building. And then the larger image that small one is set into shows a rendering of a staircase in 3D, but also on the left-hand side, a translucent yellow panel showing where hoarding will go up whilst building work is under operation. And it gives a clear, rich, context-driven information that they can just tie into straight away and understand. Again, we don't have to just do this in the office or on the site. We can go outside. So this site here had a fiduciary marker placed in the center of it, and users with the software could then just hook up and see a 3D rendering of the building before the first brick had even been laid. And so that's augmented reality. I deal more in the virtual reality side of things. So we've got classic head-mounted displays here, two different versions of technology, one giving full 3D sound, the other just giving visuals. But we also have a cave virtual environment. And the key difference here is a head-mounted display is a single user interface. One user can use it at a time. They can look around. They can feel as though they're immersed in the world. But if they were to look down, they can't see their body. And for some people, this is very disconcerting. They also find that they get very motion sick very quickly. So how can we go around this? Well, there's the idea of using caves, collaborative virtual environments, where more than one user can see and interact with the information that's being displayed. So the left image there is some previous research we did with Procter & Gamble looking at product placement on a shelf, and the right-hand side looking at some outdoor pointing of some infrastructure. And being able to work collaboratively means that if someone points at something in the environment, everyone in the group sees exactly what they're interacting with. Here you can see a larger room simulation for some internal fittings, so they could actually rearrange furniture, change painting, change lighting conditions, and see a visual representation of the room as if they were actually there. So, recent virtual reality technologies that have come out. Hopefully everyone on the call has seen the Oculus Rift. This is a Kickstarter-funded head-mounted display. Costs between $350 and $500. So the price of the technology has come down massively. But also the Samsung Gear, which is utilizing the same Oculus Rift technology, can actually use the mobile phone, the Samsung G1, as the display device. And this head-mounted device here, the phone just slots into the front of it and can be used just like an Oculus Rift. So we can start taking the technology, rather than having to send people out to site with 4 or 5 different bits of kit, we can send them out with a mobile phone, and they've even been experimenting with embedding this into a hard hat, so a worker can just flip it down when they need it. But all of this data, it's fine being able to visualize, but you need to be able to visualize the data efficiently. And big data, which is a buzzword at the moment, is a big problem for visualization because construction projects generate a lot of data, whether that's asset, BIM, CAD, or even laser scanning out on site. And different phases of the development process produce different information. So in the design phase, the visualization, we're needing the information to be able to work collaboratively. We need to be able to do design reviews. Also things like redlining, being able to mark up in a design and say something needs to be modified here or be looked at more closely. The construction phase, we've got on-site reporting, being able to coordinate data in real time, and also verification. Have I poured the concrete in the right place? We can check directly against the 3D CAD data. Once the construction process is over, however, the data still keeps flooding in. So we've got day-to-day data logging of building performance, energy usage, a whole range of possible metrics that can be recorded. And then at the end of a building life, we've got the dismantling and recycling, being able to tell if we were to recycle this, how much of a certain material would we pull out of the building? Do we need to find any asbestos and remove that individually? And as an example of big data, this is taken from Michael Batty's work from UCL. He studied 6 months' worth of Oyster card data usage, Oyster card being the contactless payment system to get onto the London Underground. And over a 6-month period, he was recording tap-in and tap-outs with a unique ID, location and time, and he was picking up 7 million records a day. That's 40 million a week, 160 million a month, which worked out to approximately 2 billion every year, and that number's increasing year on year. Now that's 2 billion data records. Good luck even analyzing 1/10 of that using Excel. So we're needing to start looking at efficient tools that we can use to really sift through that data. So how do we actually interact with data in the VR, in the virtual reality? So we're wanting to make sure we've got suitable data. So it needs to be up-to-date 3D model data linked with underlying data sets. So we need to look at the COBE information files. We need to be able to pull out asset information as we need it. We also need data to be required for task. So routing of pipe work, we're only wanting to have pipes and valves. We're not needing chairs and wall color. We also got post-data dump optimization. So some of the work that we've been doing with Crossrail, we were provided with a lot of information, and it's just 13 gigabytes is not possible to visualize in real time. So we had to do additional optimization once we'd got the data to really speed it up. And with virtual reality and augmented reality, frames per second is key. Anything less than 20 frames per second starts becoming difficult to navigate. Ideally, you're wanting 60 frames a second or higher. And modified data must be fed back into a BIM system. It's no point having a visualization system if you can't use it and then feed back information back into your CAD systems. So being able to do redlining in a virtual environment, a critical factor there is being able to get that information back to the design teams so that they can modify it so that it can be visualized again. So a quick overview of visualization research that the University of Reading has been involved in. We've been working with Bond Street Station, King's Cross, Tottenham Court and Victoria, with London Underground Transport for London. There's also been work done in the Design Innovation Research Centre around data handover, looking at the London Olympics. And we're also working closely with the University of Reading's Facilities Management Department. Previous projects have included the library redevelopment, where the internal layout was changed and bits of the building were modified. Currently, what I'm working on at the moment, working with Crossrail on the Whitechapel Station development. We're working on visualizing using both our Cave and our 3D Move. I'll be describing the 3D Move shortly. Again, working with the University of Reading Facilities Management Department, working on a combined heat and power station and visualizing the plant rooms for that. And the 3D Move prototype. This is a mobile visualization environment. We're also playing around with the Oculus Rift because whilst a single user interface is useful for a single user, we're seeing if we can network them to efficiently work with teams of people across the world. And to give you an idea, a flavor, the bottom left image there is from the Whitechapel. This is a professional rendering done of the new station concourse and ticket barriers. And on the bottom right there, you can see a user in our 3D Move interacting with the ticket barriers, and you can see the skylights there. So the rendering is accurate from the engineering data. So 3D Move, going to look at the motivation around development, the research design, and then consideration and requirements to really push this technology forward. We'll look at the hardware and software design as well as the conclusions, and then we'll have a look at a couple of bits of future work. So our motivation development, we've got publications and also anecdotal evidence from industry that there is renewed interest in fully immersive visualization. People wanting to use this technology, they're wanting to go out there and actually get their hands on it. This is drawing on significant history, so we've done previous work with the NHS Trust here in the UK, looking at redesigns of hospitals using immersive virtual reality for that. However, currently, generally this is limited to custom-built installations in purpose-adapted rooms. For example, the cave at the University of Reading is located in a room. We have 2.8 meters by 2.8 meter presentation area, and you can see the projectors there in blue folding their images off these large mirrors. And these are all bolted to the floor because they need to be perfectly aligned. The University of Reading cave back in 1997 cost about £1 million to install, and we had a couple of design reviews and meetings with Crossrail and other partners, and the question that kept coming up was, what would it take to bring immersive visualization into our office? And we kind of laughed and said, well, it's bolted to the floor, it's kind of expensive, it's going to be difficult to do. So this launched our research. So we've recently upgraded the University of Reading cave to run under Windows rather than Linux. It allows 21,000 students at the University of Reading access to the technology. We've visualized things for the NHS, as I mentioned before, Transport for London, National Rail, Crossrail. So we're working with large infrastructure projects. And we've been developing efficient workflows for visualization since 2013. So when we first started working with the technology, it was about a 3-week process to get a model from Revit into the cave. We've now managed to reduce that to an hour. And from Bentley MicroStation, again, 3 weeks, we've got down to 3 hours. And we're working with software providers to actually reduce this conversion time down even less, which will allow us to do real-time model updating. And we've been working closely with Autodesk and Bentley with our facility here for people to actually try that. So learning from the upgrades of our cave, we decided we want whatever mobile device that we had to have the same physical footprint as the cave. We wanted to be able to get 6 users in there comfortably. And you can see an image of the fixed cave there with the energy center, plant room, and the 3 users actually interacting with the data. And this drove on to our research design. So we met with industrial collaborators, and we've been working around the Crossrail project. We also went and visited one of the current visualization solutions used by Crossrail. And this identified that whatever solution we came up with had to be lightweight, portable, had to utilize modern materials, and be inexpensive. And we also decided on some user testing pilots that we wanted to go out and actually test it to see how it worked and how it stood up under stakeholder engagement and design reviews. So considerations and requirements, we wanted to make sure that we could do better than the University of Reading's cave. Currently, if we need to replace a bulb or replace a projector, it takes 2 hours of mechanical realignment to get the projector pointing at the screen correctly, which is 8 hours of my life to do 4 screens, and I want those 8 hours back. So we had to find a way of reducing this calibration time. We also wanted to make sure it's portable. The cave is 600 kilograms, it's bolted to the floor, it's not going anywhere. But also the screen design had to be foldable or rollable, because the existing cave, when it was installed, we actually had to take the back of the building off and remove some of the internal doors just to install the screens, because we couldn't physically fit them through the building. So whatever solution we have must be portable, must be flexible enough for us to take it down, set it up anywhere in the world. We also wanted it to be real-time stereoscopic visualization. That allows us to do stereo depth. And we wanted to have it to the 1-to-1 scale representation. So if a user was stood in the environment, it would feel to them as if they were actually in the environment that will be built. This allows engineers to work collaboratively. The structure has to self-support, so it can sustain all of the equipment that it needs. 2 people, small car or van, can simply transport it. And we set ourselves the challenge of being able to set up and calibrate in under an hour, ready for use on site. So, Keeping the same sort of physical characteristics of the cave, we have this cube shape. This was created using carbon fiber tubes, which are telescopic, so they all pack away down to virtually nothing. We joined them all together with 3D printed joints, which allowed us to integrate tensioning systems. We're using fabric screens, which allows us to roll them so they can be folded away and put away in the cupboard without taking the doors off to get them in and out of the building. And we borrowed the honeycomb floor panels from the aerospace industry, and they're required to tension the screens vertically. Without those floor panels, we'd just get a wavy image, which wouldn't be very good for visualization. The reason we borrowed those honeycomb floor panels is because each panel weighs less than 6 kilograms. It's very lightweight and can support the weight of people and foot traffic without damaging. So, some weights and measures. Mass of all parts, that includes computer, projectors, screen, carbon fiber, everything 78 kilograms. So 2 people can carry very easily. Once disassembled, it will pack away into any standard size cupboard. Once it's assembled, it does take up quite a bit of floor space, but as you'll see in the conclusions, this floor space is constantly coming down with advances in technology. And the usable performance area is identical to the University of Reading cave, which is important because it meant we could do side-by-side comparison of the two. The projectors we're using are ultra-short throw Optimas taken from the education sector. Not particularly great resolution, but again, identical to the University of Reading's cave, allowing us to do side-by-side comparison, and we have since upgraded the projectors to a much higher resolution and brightness. And just in numbers, for 2 people to put up, if they're both trained, it takes 41 minutes, and for 3 people, myself, instructing 2 others who had never seen 3D move before, took 32 minutes. And just to prove that, I've got a video on the next slide to show that. When we arrived at site, we had all of the equipment unpacked from the van, and you can see that sat at the front of the image. We have a time code in the bottom right-hand corner. All we've done is sped up the video, so that's 2 minutes now. The flooring goes together, it holds itself together. The tubing is all unpacked and slides through the fabric screen, much like you'd put up a tent. The corners are then joined into the 3D printed joints, and this allows us to lift up the back end first, insert the poles for the front, and lift up the front. By bringing the screen forward to the floor, we're able to tension the screens vertically, and then you can see we've got some wave in the screen. By tensioning on the internal tensioners, we can pull those screens flat. The projectors are then roughly aligned to the screens. They don't have to be perfectly aligned because we're doing the alignment in software. We log into Windows, run the software to calibrate the screens, at which point we can load our software, and from arrival to fully operational, 32 minutes, and that's with 2 untrained personnel with myself. Now, the video you see there is of the Whitechapel entrance hall, and navigating through, we're running off the Unity game engine, which allows us to have real-time lighting, allows us to do collision detection, can fly through, can take measurements off to millimeter accuracy. And the nice thing is, if you have an Oculus Rift already in your company, we can take the simulation for your Oculus Rift and within 2 minutes have it in the 3D Move. So you're developing for one piece of technology and you can then deploy it in many different types of technology. So, really cheesy thumbs up at the end there. So again, mentioned that we wanted this as a one-to-one scale. Here you can see my wife actually in the environment testing scale for me and just making sure that what she's expecting is the actual size. And we've taken this out and tested it with both Bentley and Crossrail in London. So we've transported it 60 miles from Reading to London and set it up. This was at a Young Engineers event at Crossrail. We had 200 young engineers come through the environment in a 12-hour period, and this allowed us to do some user testing. We managed to grab 35 of them and nail them down to do more in-depth testing. And this allowed us to then draw out some information which is really quite useful. So we asked a set of questions. For example, 3D glasses were beneficial for the visualization. There's strong agreement to that to allow people to judge depth very accurately. Field of view, so being able to look left and right as well as forward, allowed the users to actually understand where they were in the environment, and then how the screens, the resolution, the brightness. There's general, everyone seemed to like the environment the way it was. We then actually asked about the simulation within, and this has brought up some key critical factors that we need to address. So the level of detail within the visualization caused the feelings of motion sickness. A lot of people, in fact, 80% of them, are either neutral or above. And the reason for this is the Crossrail simulation that we had had flecks in the marble tiles on the floor. So as they were moving through the environment, the user's eyes had a lot of visual cues to grab onto, and this did cause feelings of motion sickness. In other simulations where we've just had flat textures and no real detail, we can have users working for half an hour without feeling the effects of motion sickness at all. The sense of moving around inside the building was compelling, strong agreement there, which helps towards the immersion of the user. And the fact that users felt that they were physically in the design space, again, strongly helps with believability of the immersion. And the model contained enough visual information. This was an important thing to look at. How much can we actually draw out of the model without having to go away into a COBI data file to get the information, so we can click on objects and draw that information out. So conclusions, we tested the 3D Move a number of times now, and the results of the 3D Move very close to that of a £1 million facility. It enables us to do rapid visualization of BIM data in many different locations previously that you'd only be able to do if you had an office setup. We're looking at efficient software workflows to allow us to do fast model conversion, and we're also looking at storing the equipment in ever smaller packages, or even putting it into shipping crates to ship it internationally. And we've jokingly even said that we could take it down into the tunnels of Crossrail and actually use it underground, because the whole thing will run off a generator. It all runs off a single 13-amp power supply. So future testing that we're wanting to go out and do, just to really nail down how the technology is working. We're also looking at an Innovate 18 Crossrail proposal to start using this within design reviews and putting one of these into the offices for testing. We're also looking at integration of tracking systems, which then means we can start drawing rich user information from the technology. As the user moves through the environment, we can get a real-time tracking of their position, which allows us to do things such as emergency escape from a building in the case of power cut or fire, and actually tracking and seeing how people do looking for signage. More powerful projectors we are upgrading constantly. Shorter throw allows us to get the projectors close to the environment, allows us to fit into more areas. But we're also looking at things such as native file loading and common data environments, being able to link in with document management systems, Revit, MicroStation, and IFCs to load those natively. And that was a quick run-through of the last 20 months of my work with the University of Reading. And, well, thank you very much for your time.
Thank you, Maxwell. That was superb. And it's bang on time as well. Brilliant.
Superb.
Yeah. I've got, what I've got now is the poll questions. We've got 4 questions. I mentioned at the beginning that they're multi-choice. Let me take the control back, if I can.
Of course. Okay.
Okay. What I just need to do is just skip through, let mine catch up. And the first question I've got here is, okay, what are the major interests of your organisation for incorporating advanced visualizations into your projects? And we've got multi-choice there. And yeah, early stage planning, coordination, integrated materials and progress tracking, site management, safety, quality equipment, all of the above, other, not applicable. That's interesting. Early stage planning and coordination, yeah. It's pretty much a quarter of the audience. Okay, a couple more seconds. I'll close that one out and share the results. Okay, thank you.
Interesting.
Isn't it? Do you want to make any comments on that, Maxwell, do you?
Well, it's interesting to see that people wanting to use this technology before they're actually going out onto site, and that's very important, because if we can save ourselves a lot of time and money before going out onto site using this technology, then the technology is rapidly going to pay for itself and establish its position for usage within the environment.
Sure, sure. Okay, I'll move on to the next question. Okay, which of the following tools is your organization utilized or is currently utilizing? So we've got the options there: 3D fly-through animations or static rendering, augmented reality, head-mounted devices based virtual reality, fully immersive virtual reality, or none of the above. Wow. One more seconds and I'll close this out. Okay, thank you very much. Everybody see that?
Interesting.
Yeah. Okay. Next question. What are the main instances you intend to support through advanced visualization tools? Is it design coordination, field coordination, real-time and asynchronous field reporting, safety management, none of the above? A few more seconds, I'll close that one out. Okay, thank you very much. I'll share the results.
Those results were as expected. A lot of people were trying to buy into this technology before they're actually getting out into the field. But in 5-6 years' time, I would say that those would be closer to each other.
Right, right. You mean design and field? Yeah. What about the safety management? Interestingly, nothing in there. You think that's because
it's interesting. It was dabbled with a couple of years back. It would be interesting to see if it comes back. There are companies out there specifically doing virtual reality for safety training.
Yeah.
So interesting that didn't get higher.
Sure, sure. Okay, next question, final question. What would be the largest obstacle you foresee your company facing to implement AR and VR into the information mobility strategy? Would it be cost, integration with existing technology infrastructure, safety, deployment and implementation, or none of the above? Okay, a couple more seconds. Yeah, that one. Thank you very much for voting.
Yes, indeed. That's as expected. There is always resistance around adoption of technology, especially will it play nicely with existing technology. However, cost, as people start using this technology and it becomes easily accessible and available to companies, then the cost will become less of a factor, because companies, there's a really good example from the Highways Agency where they've put iPads out on site and they've actually saved a lot of time, and the iPads have actually paid for themselves over the course of the project. So cost will hopefully come down as a smaller consideration in the future.
Right, right. Good. Okay. I'm just gonna now raise the questions, bring the questions in that we've collected during the presentation. Just bear with me a second. Okay. The first question we've got here is from Francisco Avalos. The question is, what do you think are going to be the next research areas for the future in this kind of technology applied to engineering, procurement and construction? Maxwell, did you get that one?
Sure. Well, I did, yes. I think the areas of research are going to continue in the fields of construction, especially the efficient sharing of data between different software providers, because at the moment, if you've got someone in your procurement chain using Autodesk and the majority of the procurement chain and the construction working with Bentley systems, it's making sure that you've got the efficient data sharing between the two. But also looking at how the technology is going to go in the future is, where are we going to position ourselves and how is the technology actually going to be used, whether it's in site, in the design office, or even out in the field. So the technology is improving all the time. It's just a matter of usability and user requirements.
Okay, thank you. Okay, the next question I've got here, there was mention of the projector alignment. This was done within the software. Can you explain again how the projectors are mounted and set up? And that's from Kay Moldovan. Maxwell?
Sure. The projectors currently for this prototype are just sat on the floor, unceremoniously just plonked down. They are roughly aligned with the screens, so they are pulled back away from the screen until they over-project on all of the corners and the edges, at which point in the software we're using what's known as homography, which is the ability to geometrically change the image projected to fit the screen. So much like if you mounted a projector on the roof, you have to add in additional keystoning to make the projection fit onto the screen that you're wanting it to display onto. We're doing this in software, which means that we don't have to spend 2 hours per projector finally adjusting them with small set screws and grub screws and things.
Brilliant, thank you for that. Next question I've got here is from Peter Daly. Thank you, Peter. Does the new lightweight cave just allow visualization or can you interact with BIM objects, and if so, how?
So the interaction with BIM objects is something that we're experimenting with at the moment. Because the cave is running off the Unity game engine, we've got the ability to code in C#, which allows us to then interrogate XML and IFC files, so we can actually start extracting data out from COBI data files. So whilst we're not having to load it into the visualization side, which would otherwise commonly be done, we can use the visualization as a reference or an access portal to access the data underneath. But the technology is there. We just now need to code and find efficient ways to actually interact with that data in real time.
Okay, thank you very much for that. I have no more questions. I think we've asked, all the questions have been asked have been answered. I'll move on now to the next slide, which is the announcements. We are conducting on behalf of one of our members, Loughborough University, a survey. Now, the link will be sent out tomorrow, so please watch your email boxes. If there's any questions in the meanwhile, please do get in touch with me or following. We are very keen on continuing research in mobile IT, and we want to try and support our members' work if possible, and also further the community's work too. It is intended to link with COMIT as well, whose main research is in mobile IT, and COMIT and Loughborough do have a link that goes back some time, and have been working very hard to further the use of mobile IT in construction. So any questions, please direct them to me, but if you can, I'd like to participate in the survey. Thank you for that. If the other thing as well, I'll make an announcement on, if there's any particular topics similar to today that you'd like to see presented, or you've got use cases and you think would be suitable for a monthly meeting, then please do get in touch. We are looking up through the rest of the year now. We've got some very interesting topics coming up, but please do get in touch. Upcoming events for the mobile IT community. Well, we've got the session that takes place on the 18th of March. It's the third Wednesday. Another very interesting topic coming up. You'll be notified very soon of that one. And the next event coming up is the Fiatech Technology Conference and Showcase that takes place in Florida. That's on 13th to the 16th of April. We will not have a mobile IT community in April because we will be at the conference, and we will also be running a pre-conference panel session on the mobile IT. If you are intending to attend the conference, please register for the community session. We've got a very interesting, exciting panel lined up from academia, the owners' representation, and the vendors. So please check that one out. We want to encourage people to participate. If you remember at the beginning of the slide, we've got a fair degree of interest now with 350 organisations. But there's lots of interest that's been generated through the last 12 months. We want to continue that. So if anybody has got anything interesting topics, any case studies, please do get in touch. And the last thing I want to mention is please continue the conversation. Social media with COMIT and Fiatech. YouTube, I'm asked on occasions, will the recordings be made available? Yes, they will. A few days after we've completed this presentation, we will upload them to YouTube. So please follow that link. And the other thing I will ask as well is please have a look at the follow-up survey that comes out. We do highly value your feedback, so please keep the information coming. Now, we've finished a little bit early today, but Maxwell, I'd like to say thank you very much to you again. Very interesting topic.
Thank you very much for the opportunity.
Sure. I don't know if there's anything else you want to say, but thank you.
Well, just thank you to everyone for listening, and if you are interested in the research that we're doing and want to find out more, it can all be found on our website, and that was included in the original invitation that was sent out, so please do visit our website for more information.
Okay, thank you, Maxwell. Thanks to Fernando for his input, and thank you to everybody for joining us today, and we'll see you on the next one. Thank you. Bye-bye.
Thank you.